Hi guys and girls, welcome back to BBR Suspension. So today will be the second part of the Porsche 904 suspension build. So today we're going to take some more solid 4140 and we're going to get cracking with the camber adjusters. So like I explained in the first video, there's a couple of parts that are, number one, either not available in South Africa or not available anymore, such as the the ball joint with the straight shank or straight sleeve that was used on the original top arm. So what we are going to do is we're going to design and basically fabricate or build a camber adjuster. So on the originals that I showed you, the clamping mechanism was quite a hefty, chunky thing, and the problem that one had is that you had to loosen the pinch bolts and physically slide that ball joint shank left to right. It wasn't anything that was sort of adjusted where it could remain. So it was a bit of a hit and miss, and it was quite a difficult adjustment. So I've come up with an idea of doing a left hand thread and right hand thread for a camber adjuster, similar to sort of the concept that's used on modern tie rods on vehicles. So we're going to get cracking. I've got still some 4140 and we're going to get cracking machining the camber adjusters. Fair amount of machining involved in these, so let's not waste any more time. Let's get cracking. Hope you enjoy this one. Right, so we're going to get started with the camber adjusters, and how we're going to do this is we're going to first do the internal thread that the rod end will thread into. This internal thread is going to be a M14 with a 2mm pitch, and to be able to do that we've got to tap a M14 thread that I do have a tap for. So we'll do that, which you'll see shortly, and we start off by drilling a 12mm hole through the stock to accommodate the tap, and we will then tap the thread. Right, so now that we've got the internal threads done, we can start hogging away material. This is going to take a little bit of time. There's quite a bit of material we've got to take off. Remember, we're machining it down to do a M20 thread. So we're starting with a 40mm bar, got to take 20mm off the diameter. So this is going to take a little bit of time. 4140 is pretty hard stuff, so we'll machine a little bit. Because of the speed we got to run on 40mm OD and smaller, coolant will just spray everywhere, so I'm doing it without coolant, and we'll stop every now and then, let it cool off a little bit with some more coolant, and we'll machine it down to a 20mm OD. So let's get going. around. Right, so now that we've got the front section machined down, we'll flip it over. And what we'll do, we're going to machine a nib on the back. Okay, so the nib is going to serve two purposes. It's going to allow us to hold the unit or the part while we machine the thread on it in the lathe. And then it's going to allow us to machine a hex on, which is going to be the nut on the camber adjuster. So that you'll see a little bit later on. But what we'll do, we'll start by hogging a bit of material off and measuring the thickness of the flange that remains. That flange will ultimately become a nut, or let's say the head of the bolt. Let's rather call it the head of the bolt. So we'll machine that little bit of excess material off, just so that we've got something to grab onto. And then later on you will see where we machine the actual hex on, and that will then become the nut, which is used to turn the actual body of the camber adjuster. And that'll give you your inlet and outlet, let's call it projection or retraction of the actual camber adjuster. So we'll just hog off some extra material until we get it down to roughly the same diameter as the opposite side. Just something that we will be able to grab in the chuck, and then we'll machine it off right at the end. Right, so now we've got the nib machined. We'll flip it over in the chuck and we'll get some die cam on and get it prepped. The next stage is going to be to cut the thread, and this is going to be a M20 by 2mm left-hand thread. So we're going to do this thread slightly different to the conventional threading. We'll be threading in the opposite direction, but we've got the die cam on. We'll give it a few seconds to dry. Right, so now we are getting into the left-hand thread cutting, and we can see that the thread is going well, so we can basically pick up the pace a little bit. Because of the stick out and I'm not using a live center, I'm doing pretty light cuts at the around about a 0.25 mil depth of cut, absolute maximum, but I'm trying to keep it at about a 0.2 so that we don't get too much deflection on the actual workpiece. Slow and steady wins the race, and we'll get there at the end, but a 0.2 mil depth of cut roughly. And because I can't change the compound to a 60-degree angle every second or third cut, I'm just giving it about a 0.0025 offset, just so that we don't get any drag on the actual tool bit. But so far it's looking good. We're getting the cut smooth, and within a couple more passes we should have the M20x2 left-hand thread done. Right, so the next part we're going to be making is the locking nut. I've parted off some hex bar, drilled it out, and basically we're going to be using a left-hand internal threading tool. We're going to have to run the lathe backwards. You'll notice the chuck is spinning clockwise versus anti-clockwise, the conventional route. So because we're going to be machining a left-hand thread, spinning the chuck clockwise, we'll be machining inwards rather than outwards on a conventional, or shall I say anti-clockwise on the chuck, the conventional right-hand thread. So these nuts also have to be left-hand thread to go onto the end of the camber adjuster. Right, so machining the left-hand internal thread on the locking nut gives us two things. It allows us to check the thread that we've machined on the actual camber adjuster, that's the male thread, and then what it does is it gives us the parameters to machine the thread on the sleeve. It's far easier to check on a nut that's approximately 8 millimeters thick versus a sleeve that is 55 millimeters long. So if you make a little bit of a mistake on the thread, it's easier to fix it now on a short part, and it's a part that can be scrapped and redone if necessary, versus actually having to redo a 55 millimeter long sleeve where it's very difficult to obviously see inside if there is a mistake on the thread. So that's the point of doing the lock nut like this. Right, so now that we've got the lock nut machined and got the thread parameters figured out, we can do the sleeves, and these sleeves will ultimately get welded into the actual tubing of the top struts. But basically what we've got to do is machine the same left-hand internal thread into the sleeves that the camber adjuster will screw into. So now that we've got those parameters, we can basically do these. We'll stop and check every so often, and what we'll do is we'll give a little bit more, we'll cut away a little bit more on these sleeves, because when you weld, generally after welding a part shrinks slightly, so we'll give about 2/200ths of a millimeter extra on the threads on the sleeves, just to allow for a little bit of shrinkage after the weld. But the procedure is pretty much the same as the locking nuts. It's the same thread pitch, thread diameter that we're cutting. So we've sped it up, and hope you enjoy the therapeutic watching. experience. Ja, dat is het. Dat is het. And now we'll head back on over to the lathe. Now that we've got the hex machined, we don't need the little nib on the end anymore. So what we'll do is we'll get set up in the lathe. We'll first just chamfer off the corners on the hex, just take off the sharp bits. And then once we've done that, we can machine the nib off the back. Once that's done, we'll just put a little chamfer on the internal thread so that the tie rod or the rod end can thread into the camber adjuster, and then we're pretty much done with the camber adjuster. So yeah, enjoy watching the nib getting machined off. Righto guys, we've gotten through quite a lot of the machining on all the bits and bobs that we're going to need for these Porsche suspension brackets. So the first I've machined up all the sleeves, so these sleeves are going to basically be the pivots. So the actual strut will get welded onto these sleeves, and that will pivot on a polyurethane bush which attaches to the chassis. Then made up 8 of those. Then these little sleeves go through the lower control arms, and basically the shock absorber will mount over here between the sleeves, and those then ride up and down, and there's two that go upright through the lower control arms, which is for stabilizer bars. So those are made up, and then we've had to do a little bit of improvising, like I explained earlier on. There's certain parts that are no longer available, or well, just not available in South Africa at least. So what I've done, instead of using a ball joint on the lower control arm, we've made up some housings for the spherical bearing. So basically show you the spherical bearing can turn in pretty much any direction. So what we've done is we've made up the housings for the spherical bearing. All I've got to do is just drill and tap a hole for a grease nipple on these, but that we can do a little bit later. So those are done. And then for the upper control arm, I've come up with a design for a camber adjuster, because the ball joint with the smooth shank or the straight shank isn't available anymore. That's something that hasn't been available for quite a few years. So what I've done, I've machined up these parts which have a M14 internal thread, which the rod end, which is going to be used as the upper ball joint, rod end will screw into there, and then I've machined a sleeve with a left hand thread. So when you need to do your camber adjustment, then it's as simple as loosening the lock nut, rotating this hex and turning it anti-clockwise will basically tighten it into the sleeve as well as pull the ball joint in, or clockwise will push them apart. Similar to a standard shackle that you would use for tensioning cables. Same concept, except we basically got a coaxial thread one within the other. Okay, so those I've machined up, and those are working well. I should be getting the rod ends probably later today, and we can just check the fitment, but those are all done. I will be honest, it was quite a challenge doing the left hand internal thread over that length, single pointing it. Unfortunately there were no M20 by 2mm left hand taps available in South Africa, and the price to get one in was just exorbitant. So that's the camber adjusters, and you can see the left hand thread screws into the fitting. So this will get welded on the upper control arm. The arms will go basically either side and around to these bushes. Right, so I think we're pretty much done with most of the machining so far on this, but for now we're going to call it on this one. So guys, thanks for watching. If you like what you see, hit that subscribe button, give the video a like. Let's grow the channel, and we'll see you in the next video. Thanks for watching guys. Take care. Ciao.